and welcome to Autopsy of Vulnerabilities. This is my session about we're going to review 3 different vulnerabilities and explain them to the code so we can understand how they work behind the scenes. First of all, let's say thank you to our sponsors. Thanks to them, because without them, this event would not be possible. So thank you, our diamond sponsor, Akia. Thank you, platinum sponsors, Wunder and Platform SH, and all our gold sponsors. Thank you all. So, who's me? I am Ezequiel Seki Vasquez. Seki is the shortener, and I am a backend developer. I have been working with PHP since 2006, and with Drupal specifically since 2012, I think. So it's been more than 6 years now. I have also some background on system administration and DevOps, and I am really passionate about hacking and IT security. And well, I have been also collaborating with local meetups and universities there in Spain since 2013. I currently work for Lalabot, and well, this is something like I am not only a coder, I am also a human. So this is a picture of Jerez, which is my hometown. I am also a Harley-Davidson rider. That's a picture of the fuel tank of my bike. I have 2 pet rabbits, Kiro and Hopi. And I would love to say that I have a rock band, but that would be not true. So I will say I play sometimes the electric guitar. So that's me, and this is what we are going to talk about on this session. I'm going to give a brief introduction, just a couple of concepts, so we can follow everything on the presentation. Then we're going to analyze these 3 vulnerabilities, and well, you will see the format that I will follow. And then, as a conclusion, as a summary, we will discuss the risks we can face if we don't patch properly our systems. So that's it. Let's start. First things first, what is a vulnerability? Well, a vulnerability is nothing else than an error on the code or on the configuration of a site or of a software system that produces that an attacker can change the behavior of the system. For example, injecting code or extracting data that should be not accessible, whatever. And a patch is a piece of code that we apply to our system so the vulnerability is fixed. So the error is not there and the attacker cannot change the behavior of the system. And the life of a patch is, well, in general, of course, this is a generalization. First, the vulnerability is discovered maybe by a maintainer of the core, for example, on Drupal, or by the security team. I want to do a small break here. Thank you, security team, for all the work that you do. We are safer. Thank you for that. So, so once the vulnerability is discovered, the security team will work with the maintainer of the module or with the maintainers of core or whatever, and they will create a patch so the vulnerability is fixed. And then a new release, both for the module or for the core, is published, and everyone runs to download the patch and to apply the patch. Hopefully everyone does that. Not everyone does that, but, well, you know what I mean. What's the problem? That when we release the patch is available for everyone, including security researchers, hackers, and attackers that want to guess. They just try to guess how this vulnerability works and how it can be exploited just to get profit of it. So they study the patch, they extract the information, and then they create a proof of concept, which is basically an exploit, a piece of code that allows to change the behavior of the system, as we discussed before. And once this proof of concept is published, then what usually happens is massive attacks start to happen. We will discuss possibilities on this on the last section. So, yeah, I will patch my system. I trust the security team, of course. I trust the new release, and I will apply the patch. But the problem is, so many people apply the patches without understanding how they work or how the vulnerability works. In fact, this session came because a person from the Spanish community told me, okay, Seki, I don't understand how this Drupal Get On 2 patch works. I don't know how the vulnerability works. So yeah, that's basically what we are going to try to do here, to explain how they work. So let's go for it. First vulnerability is Drupal Get On 1. If you remember, this was on October 2014, and it was an SQL injection as anonymous user. This means that any user of the site, any anonymous user, they don't need to be logged in. They can execute SQL commands directly to database. Boom. So the naming convention for Drupal vulnerabilities is SA for security advisor. Core in this case is because the vulnerability affects core. The year and then 005 means that this was the fifth vulnerability, the fifth security advisor for that year for the core. There is also other naming standards, naming conventions. In this case, CVE is for all software in the industry. And well, that was the number of this Drupal Get On 1 vulnerability on the CVE system. All Drupal 7 prior to 7.32 were affected. And, well, I'm going to follow this format. First, I'm going to describe the vulnerability formally with a screen like this one. Then I'm going to mention a couple of details of day-to-day technology components that we use and that are involved in how the vulnerability works. After that, having in mind, these components, how they work, I'm going to describe the vulnerability, and then we're going to see it live. So, fingers crossed. So, okay, just quick something quick. If you remember, we used the HTTP post method to submit values, form values, basically, but we can use for other things that not form only. So we use post to submit values to the server. And usually those values can be integers or strings, but they can be also arrays. So if this piece of code is the HTML rendering of the user edit form. If you remember, if you want to change the password, you have two passwords fields, and this is how they look on the HTML. We have the name of the variable is pass, and then we have two indexes, pass1 and pass2. Each one is for one of the fields. On the server, I don't know if you can see it properly, but that's like the content of $post pass in the server once you submit the user edit form, and you can see pass is an array with two indexes. Pass1 has 1, 2, 3, and pass2 has 1, 2, 3. Don't use this password, please, ever. So, in summary, we can submit arrays on the post calls. So. That's one component that we want to mention. Another component, database queries sanitization. We have to not trust any input from the user. Every input from the user, said in the other way, should be sanitized, because we can be in risk if we accept any input without sanitization. So for database queries, Drupal 7 used expand arguments function, which you can see here, and this is to sanitize arrays. Just imagine that you have an SQL query with a condition like column name, in, and then an array of values. Okay, so to sanitize those values, we use this function. I have added, you can see 4 print Rs there, just to use on the next slides. So let's imagine again the user edit form. You are an admin and you are going to modify the different roles that a user account has available. Then you have a list of checkboxes, one checkbox per role, per available role. And you want to assign roles with RID 2 and 3 for this user. So you are going to check the two roles, then you're going to submit the form. This is what is sent from the browser to the server. It's an array named roles. With key 2, you have value 2, and with key 3, you have value 3. It's really simple. So this is not the real query for changing the roles, but I will use this query just to describe the component here, the technology piece. So for these 4 print Rs on the expand arguments function, the first one is the array name. In this case is RIDs, role IDs. The second one is the original value of the array. We have the array is 2 and 3, and the 0 and 1, the keys are the implicit keys. So you can imagine that this array on code would look like array parentheses 2, 3 and close parentheses. Okay? So we don't have explicit indexes. After the expand arguments is executed, then we have an array looking like the third one, which is, I have the cursor, like this one. And what it's done, it's it assigns specific, explicit indexes for the arrays. In this case, we use the name of the array, underscore, and then the value of the implicit index. So 0, 2, 1, 3 becomes RIDs underscore 0, 2, and RIDs underscore 1, 3. It's easy. And then, as a last part on this expand arguments function, the query skeleton is built. You can see on this part, on this condition, r.rid in RIDs 0 and RIDs 1. So we are using the new explicit indexes as placeholders. So Drupal will sanitize the values and then will inject them on the query. So everyone understands at this point that these 2 pieces. Okay, that's it. How the vulnerability works behind the scenes. Okay, so the problem is the array indexes are not sanitized properly. So we can, like this, modify a variable, which is in this case a string. Name is, in this case, for example, admin or whoever username you want to log in. And we transform the name variable into an array, and then we inject SQL, an SQL query into the index. Okay, this is the format. So we're going. This is a Postman call. A Postman screenshot. This software is used to execute different HTTP calls, and we are going to replicate the user login form behavior. So we're going to post to /user/login. We're going to submit from ID is user login form. We're going to poison the name variable and then pass. We don't care about the pass because we are not going to log in. We're going to hack into the database. So remember those 4 print R's instructions. This is how they will look with this input, okay, with the form ID, the name, and the pass. So it's an array which is going to be used on a database query, so it needs to be sanitized by expand arguments function. So the first one, name, is the name of the array. Okay. So the original values for the array is 0, semicolon, delete from cache. This is so just for the example, semicolon, semicolon, and then a hash with value admin. And then we have transformed the name variable from a string to an array, not only to inject here, but we need a real, alleged value. I will explain now the reason. So here is the variable, the vulnerability. The index is, the explicit index contains still the injected SQL query, and this is how the final query looks. So we have select all from users where name equals name 0, which is going to be properly replaced to admin. That's why we need a real value. So this query is executed, and it finishes with a semicolon. But then this other query is going to be executed. In this case, delete from cache. Okay, and we insert 2 semicolons to be sure that this is executed, and then the hash is a comment character on the SQL language, so we can ignore the database engine will ignore the rest of the query. So we have 2 queries instead of 1, and we have been able to insert arbitrary SQL. So let's see it. I have here a Drupal 7.31. This is basic installation. I have not prepared anything. And I'm going to go in. Nope. Okay, I'm going to go inside of the database. I think you can see it. Yeah. So I'm going to show you select mail from users where UID is 1. This is the admin, the email of the user with UID 1 for the admin. So now, let's go back to the user login form. Let's edit the HTML. And what I'm going to do is to duplicate the input for the name. The second value is going to be the legit value, so name 0. And for the first one, what I'm going to do is to insert 0, semicolon, and then update users set mail, sorry, equals lalabot, sorry. Now, sorry for that. Update user set mail equals seki@lalabot, where UID equals 1, then semicolon, semicolon, hash, and 2 spaces. And that's it. So we have now 2 different fields. So I'm going to use the same values done in the example, admin, admin, and then 1, 2, 3, 4. And I'm going to try to log in. So, yeah, an error, unrecognized username or password, okay. But what happens now? Thank you. So basically I have changed the email for this admin account. I can now go and request a new password. The one-time login is going to be sent to my email, and then I will change the email again using the same technique. And these couple of update queries are not going to be logged anywhere. So no one knows that I have admin access to the Drupal. So this is why this vulnerability is so dangerous. We can, of course, extract the database. We can use it to do a lot of stuff. For example, we could even try to execute code by changing the cache tables. But well, I will not explain this because it's very complex, but it's possible. In fact, the vulnerability on the module services is related to that. So let me start the second container while we continue with the presentation. And we are going with good time, so that's nice. Okay, so this is Drupal Get On 2. This is from March 28th from this year. If you remember, the security team announced this patch 2 weeks before, I think. I don't remember exactly. But they really did a good job because of all the noise about this update, a lot of people actually applied the patch. So yeah, that's nice. So this vulnerability is SA core for this year 002. On CVE is 7600. And it's a remote code execution as an anonymous user. That means that any visitor, any anonymous user can execute PHP code on the site. And if you can execute PHP code, you can do whatever you want. So all versions of Drupal, both 5, 6, 7, and 8 were affected. And the patches were 7.58 and 8.5.1. And this is a screenshot of the C99 PHP Shell. And this is basically, imagine that you can upload a PHP file to the files directory, and you can then open that file on your browser. And what if that shell gives you access to shell execution, server level? You can list directories, you can, for example, cat settings PHP, and then you have the credentials for the database or whatever credentials that are on the settings PHP file. So you can start imagining. And even if you have Netcat, for example, installed on your server, you should not have Netcat installed on your server on production. Then they can have direct access to the server without needing the shell. Okay, just keep that. Keep this C99 shell in mind, please. So. Sorry? Yeah, sorry. The NIST index is an index from 0 to 25, where we can specify how risky, how dangerous is a vulnerability. 0 out of 25 is not a vulnerability, nothing to worry about, and 25 out of 25 means we are all in danger and you should patch now. So this NIST index is built out of, if I remember correctly, 6 different attributes. Each attribute has a score from 0 to 4 or from 0 to 5, depends on the attribute. And then attributes like, okay, this is theoretical or it's practical. It can be actually exploited. This is, you need to be logged in, you need to have permissions, or you can do this as an anonymous user. Then depending on those attributes, you have more score on your vulnerability, and if you have 25 out of 25, like Drupal Get On One, it's like, okay, this is my site. It's yours. So, yeah, thank you for the question, because I forgot to mention before. Okay, so let's talk about renderable arrays. These arrays came from first Forms API. Forms API, if you remember, is a mechanism to build HTML forms, and each field corresponds to an PHP array. This PHP array, to define the HTML form field, has some specific indexes which start with hash character. So, if you remember, we can define a password field, for example, with hash title password, hash type password, and then hash length, I don't know, 32, whatever. In fact, I think length is not a real, well, whatever, you know what I mean. We all know. So this kind of arrays, PHP arrays with a specific keys, starting with character, with a hash character, sorry, can define forms. So on Drupal 7, this mechanism was generalized, so it was used to render everything. For example, if you remember how to define a block on Drupal 7 programmatically, you have an array with hash title and then the title or name. I don't remember exactly. It's been ages since I touched the Drupal 7. But if I remember correctly, it is hash title and then the title of the block, and then hash content and then the HTML of the block that will be printed on the page. Or you can have an array, which is also a rendered array. And then this is, the block will first render the content, and then the block itself which will wrap the content. So the behavior is recursive. If you have nested renderable arrays, then Drupal will start rendering in the deepest, and then go to the parent and render, to the parent and render, until the HTML is fully rendered. Something to take into account about these renderable arrays are the callbacks. These are PHP functions that will be executed to respond to any events on the render process. For example, post-render will be executed after the rendering process has taken place, pre-render will be executed before, etc. And, well, let's keep in mind that HTTP post can submit arrays, not only integers and strings. And if you type some values on a form and submit the form, and the form is not validated, then you're going to have the values that you introduced before on the form. So those values for each field, let me rephrase, the value of a form field will be stored in hash value in the renderable array of the form. Okay? That's it. So the hash value will contain the value of the form. So having into account, having these three things in mind, let's describe the vulnerability. So what we want to do is to submit an array in a form field where Drupal expects to have a string. Okay? And this array will contain indexes with char, with a hash character. You can see here what we're going to do. We're going to replicate the user register form behavior. So we're going to post to user register, and we're going to include the form ID. And then on the mail field, what we're going to do is to create a fake field. with a post render, which will be the exec PHP function. So we are going to try to execute at server level. Then the type will be markup, because this is a field. This is a renderable field. This is not needed on Drupal 8, by the way. And then on markup, we're going to have the payload, the code that we want to pass to exec in this case. So how we can send this, but Drupal is smart enough to not render this array, because, I mean, Drupal expects a string. So we need to trick Drupal to renderize that email field again. How to do this? With Ajax API. Just think about the user register form on Drupal 8. We have a picture field, and we have the examine. Okay, so we can select a picture, okay, this picture, my avatar, for example, and it's going to be submitted to the server using Ajax. And then, once this request is finished, Drupal is going to return some piece of HTML, and it's going to replace the field by the thumbnail of the picture. So we're going to use the same mechanism, but we're going to tell Drupal, okay, do the same, but with the email field. And the email field has a renderable array. So you have to re-render mail, and then we have a post render here with this exec. Okay? So it's not hard. So to trick Drupal, what we're going to do is use these 3 different get parameters: wrapper format Drupal Ajax, Ajax form equals 1, and then element parents, which is the hash value. %23 is hash character, but URL encoded. Okay, so that's it. Let's see it. I'm going to run a bit more because I am a bit behind time now. So just for you to know, to see, this is the user register form. And, okay, this is the value of the email field. Let me, for example, if I try to introduce something which is not an email, and I try to submit the form, then the front-end validation is going to tell me nope. But what if I use, this is something similar to post. What if mail on the post request is a renderable array? Let's try to send. So this is the content of the form, for the form field mail with an injected renderable array. And now let's use Postman and let's do it. So this is exactly, please close the sidebar. Thank you. This is exactly the same that I have displayed. So what I'm going to do is to show you that on the files directory, sites default files, we only have the standard directories. We have no files there. And on the Postman, we're going to create an TXT, a plain text file. We're going to say hola. We are really polite, so we're going to say hello. And that's it. So let's execute this call, send. So we have a 200. And then we have here our TXT file. And we can even say cut, the content. So imagine instead of a plain text file, if I inject the C99 PHP Shell, I have control over your server. So yeah, that's basically it. That's how it works, Drupal 2. I'm going to really run because I want to show you Drupal 3 too. So I'm going to be a bit more quick now. So Drupal 3, it's also a remote code execution that can be achieved by an authenticated user. That's why it has a 20 instead of more score on the NIST index. Things to take into account, the destination parameter. If you remember, if you load a form with a get parameter named destination and then a URL, when Drupal finishes processing the form, it will redirect to this URL. What happens? It happens that the destination value is passed to strip dangerous values. It's a function introduced on the patch for Drupal 2 that basically cleaned everything that looked like a renderable array. But what happens? That the double encoding is not detected. If you get the hash character and URL encode it, you have %23. And if you URL encode it again, you have %25, which is actually %, and then 23. So this was not sanitized. And then also on the Ajax API, we have an option which is triggering element name. This option identifies the element of the form which was used to submit the form. Imagine you have an Ajax form, you have 3 different buttons, button 1, 2, and 3, and you use the button 2 to submit the form. Then triggering element name will be a reference to button 2. That's it. What happens? This option, I don't know how it works, to be honest, but this option makes this button number 2, to be renderized again. Okay, so you now have, we can inject renderables array on the destination, and we can now force renderization using triggering element name. So, how the vulnerability works. This is done in 2 different steps. The first step is that we're going to perform a post call to an URL, to the URL of a confirmation form. For example, node/1/delete. But instead of just accessing using the browser, we're going to do a post call because we want to include these 3 different parameters. So Drupal thinks that the form has been submitted, but it does not validate, so it's going to return to the form again, but we have inserted the triggering element name here. We're going to set the triggering element name to form ID, and this, I am not 100% sure about this, but this will force the form to be rendered again, fully rendered again. And on destination, we're going to inject the poisoned field, which is a renderable array with a poisoned post-render callback. So again, I am not 100% sure, but this destination parameter, the value, is going to be inserted on the form array as hash redirect or something like that. So if we render again the form, remember that we're going to be rendering the deepest renderable arrays, and the destination callback is going to be rendered again. And yeah, this is the URL we're going to post to. This is the content of the post call, and then we're going to post to node1delete, and then on the destination we're going to include the post render. You can see here the %2523, the post render, which is going to be passed through because this test is done against Drupal 7. The difference with exec is exec returns output as a string, and pass through returns output as a binary. And then the type of the field is markup, and then the markup is the same. We are polite. We are going to say hello. That's it. And then we have everything in place. So the form is poisoned, and we only need to submit the form. So what we are going to do, submit the form using the Ajax API. So what we're going to do is to execute the cancel action of the form, but using Ajax. So we're going to post to file Ajax actions cancel hash options path, and then we're going to use the form build ID from the form that we have just rendered. So Drupal knows, okay, I have to render again this same form. And then Ajax API processes the form and executes the post render. Let's see it. So let me show you. We have, really quick, I need only 5 more minutes. So this is a Drupal 7.58, okay, and just to show you. And on Postman, I have prepared, of course, on this sidebar, Drupal get on 3 first step. This is exactly what we have seen on the presentation, on the slide. The body is here, the form ID, etc. And on the headers, I include a cookie because, of course, not everyone can access to the node delete form. Okay, so I am logged in as an admin, but this is just for the demo, of course. So first, I'm going to please let me. The trackpad hates me. Okay, sorry for that. So I'm going to send. We have a 200. Okay, and we're going to see on the preview that we have been redirected to the form. Drupal thinks that the form has been submitted before, but it does not validate, so we are back to the form with everything in place. And what we are going to do now, we're going to execute the second request, the second step. In this case, again, we are logged in with the same cookie value, and we're going to execute file Ajax action, blah, 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 with the form build ID. I have forgotten to get from here the form build ID. So Drupal knows its form build ID is this value. So we can tell Drupal, okay, render this specific form again. So let me just replace this and this, and we are all set. So now we are on Drupal get on 3. Sorry for that. Drupal get on 3. So doc root, sites default files, and we don't have anything here. And now I'm going to submit using the scroll bar here, the payload. We have a 200. And now, again, we have been able to upload a salute. Thank you very much. So I'm going to, that's it. Those are the 3 vulnerabilities. You know now how they work behind the scenes. And, well, let's discuss really quick what happens if I don't patch, you can imagine. So if you don't patch, what can happen is, first of all, your database is going to be dumped by the attackers. So you're going to lose all your, well, you're not going to lose the data, but you're going to have a problem. Especially with the GDPR stuff and so. This is really popular. If you can execute PHP code, and specifically you can execute commands at server level, if you can use curl or wget to download a file and then to /tmp, to temporary files directory, and then you can execute something there. It doesn't matter that it's using the Apache, well, the web server user. This is a real screenshot of a cryptocurrency mining malware on a real server, on production server. You can see the 4 cores, the 4 CPU cores are at 100%. They have load average 444, so this has been running a lot of time. And if you see the column for user, it's root. This is a real screenshot. So please patch your systems because you are in risk. So what happens, another option, your server can be used as a proxy to do illegal stuff. So I can hack into your server, I can use your server as a proxy, and then your IP address is the one that is going to be logged on the servers I attack. And even if you are not doing anything, because you are not the hacker, you are not the attacker, sorry, your IP address is the one that the police is going to find. So you are in trouble, because you are responsible of your server. And what if I don't want to use your server to attack other servers, but your users? If you have huge sites with, for example, 1 million users, I, as an attacker, have 1 million potentially zombie laptops that I can try to infect with cryptocurrency mining malware. And instead of using your server to get Bitcoin, I'm going to have all your users' laptops to get cryptocurrency stuff. So take care of your users, please. Yeah, the possibilities are a million, so I'm going to finish now. Just a summary, please, security training. It's not so hard, seriously. You only need to study a bit how these vulnerabilities works. You only need to learn about the best practices. And of course, please, 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 patch your systems. Thank you. So if any of you have any question, please, is the moment. It does.
Hey, I know you ran out of time, but the thing that we probably needed was how the security issues were mitigated by those patches, like how they were cleaned up and something.
Sure. So for Drupal Get on 1, the patch basically fixed the span arguments logic, so the indexes of the array were properly sanitized, so you cannot inject SQL again. And for Drupal Get on 2, what the patch basically created a function to remove any value from GET requests post, request, and even cookies, basically to remove everything that looks like a renderable array. So every array that has an index starting with a hash, it was removed. So you cannot inject a renderable array. And for Drupal 3, it's basically the patch was to make this strip dangerous values function aware of multiple encoding. So you cannot use the %2523 trick. Those were the fixes. I think that's okay. So any other question, please? Don't be shy. Oh, we have a question here.
Thank you very much, first of all, for this talk. Yeah, so actually we need to ask if never trust your users, actually it's never trust your APIs, that's the new word, right?
Sorry, can you repeat, please?
Never trust your APIs anymore, because when we're going to microservices, so a question would be just allow text or max length strings anymore? So would you go for very heavily sanitizing your inputs and not actually allowing JavaScript objects or objects at all, or arrays?
Well, I don't know. Give the microphone, please, because I'm so sorry, but I have not understood everything. So can you speak a bit slower, please?
Yes, I can.
Thank you.
Try.
So sorry.
My question generally would be how to secure APIs.
APIs, okay. So to secure APIs, you basically want to do the same as securing any other piece of software. Just don't trust any user input. You receive an array, clean the array, sanitize the array. You receive an integer, check that it's really an integer. And of course, you can use authentication. You can use, for example, SSL certificates to verify that the client is a legit client, or authorization using username and password. Just implement the best practices. But specifically for the user input, just clean everything. You have to not trust anything that comes to your API. That's basically it.
Hello. What do you advise to get more security? What tools do you advise? External tools or modules or best practice, whatever?
Sure. Well, the basic is subscribe to the newsletter of security of all the tools that you use. For example, if you use an external JavaScript library, subscribe to the newsletter of that tool. So you are aware every time that a security issue is announced, and you can patch quickly. Because if you are not subscribed, then you don't know if that tool has received a patch. Of course, you can apply a lot of best practices, but that's the most basic advice. Just keep up to date with all your tools. And we tend to use a lot of tools on our projects. So it's a lot of newsletter, but it's worth. Okay. Yeah. So you mean another external tools?
Yeah, external tools.
Yeah, sorry for that. I misunderstood. So, well, on your server, first you want to use a firewall. I don't know if you're familiar with the concept of security in depth. That means that your application, your project is built of different layers, and you have the external layer. You want to secure that with a firewall, for example. So only requests to 80 and 443, in the case of a web project, are allowed, but only to the inside. If you don't need to consume any external API, you want to block outgoing connections. Yeah, for example, or just block everything unless you want to explicitly allow that. Then in the inner, that's the external layer. In the inner layer, use, for example, mod security or some kind of web application firewall like Snort or whatever. Suricata is another option. Then at Drupal, at server layer, you have plenty of best practices to secure your Unix server, Linux or whatever server you want to use. Close the ports, audit the users, the permissions, etc. At Drupal level, you have multiple modules, security review, you have, I don't know, thousands of them. And yeah, it's basically it. On each layer, you want to use at least one countermeasure. I have 1 more minute. 1 quick minute. Just okay. Yeah. Just think about Lord of the Rings, the Two Towers movie. If you remember, on the Helm Abyss, they have the citadel and then the wall. But the orcs destroyed the wall. So they had only 2 security layers. But boom, and we have only 1. And they had the problem, so Gandalf had to come on the 5th day. So don't be like the Rohan people. Have multiple layers, multiple walls. So that's it. If you have any other question or the comments or whatever, please stop me on the hall and tell me whatever. Thank you for coming and for enjoying the presentation.